Hello, this is Stephen Withrow with WebEducator. In this video, I'm going to show you a solution Brian Randall came up with for a prototype design pattern in Java. Brian agreed to let us create this video showing his solution, which is available as an article on his blog at the URL shown here. The prototype design pattern is an example of a creational pattern. This involves use of a prototype by which other objects can be created. The prototype will serve as the original copy. We will make clones of that object and change properties as necessary. The implementation involves implementing the Cloneable Interface. This is required by the Java runtime environment. The Cloneable Interface is a marker interface and does not contain any methods. Brian provides a prototype interface that extends Cloneable. One method is listed in this interface, the clone method. The class that we wish to clone will contain an implementation of this method. To exemplify this, Brian gives us the sheep class. The sheep class implements prototype. The sheep class has a property, shepherd. The sheep class provides an implementation of the clone method. Notice that the clone method is going to call the clone method in the superclass. This will be Java Lang object. This is a requirement in Java for cloning an object. Then we will set the properties of the clone, copying those properties from the original object. We need to ensure that the properties of the object, in this case shepherd, are clonable as well. Notice that shepherd implements the prototype interface Brian provides and provides its implementation of the clone method. Brian provides a main class that serves as a tester so that we can verify that indeed we can create a clone of the sheep. I have recreated Brian's code on my computer. I have added an additional property to the sheep to indicate what happens if we are not careful to call the clone method of a particular object. I have commented out the line that calls the clone method when we get the breed for the cloned sheep. The line of code that I have active right now simply sets the breed, and it does not call the clone method of the breed that we are obtaining. What we will observe is that our object is not a true clone. In other words, the pointer to the breed in the original object and the clone will be the same. The shepherd, however, will be a true clone. Let's verify that. I'm now going to compile the Java classes. The Java classes includes the main class, which is our tester, the sheep class, the shepherd class, and the breed class, which I have added. Everything compiles fine. Now we're going to run the main class. We create the original sheep, as I call it. This is our prototype. The shepherd for the sheep is Joseph. The breed of this sheep is domestic. Now I create the clone. The shepherd name for the clone is David. The breed of the cloned sheep is wild. I will now display the original sheep. Notice the shepherd name for the original sheep is Joseph, which is correct. But the breed of the original sheep is wild. That's the breed of the clone. What happened is the pointer variable for breed is pointing to the same breed object, and that is not correct. This is the breed class. The breed class implements the prototype. The breed class includes a clone method. This is very similar to what we see in the shepherd class. I will comment out the code that sets the breed by calling the getBreed on the clone. I will uncomment the code which calls the getBreed and then calls the clone method so that we get a copy of the breed for the sheep, which is exactly what we are doing for the shepherd. I'm going to save that change. Now I'm going to run the main class again. If we look at the output, now the breed of the original sheep is domestic after we have created the clone. Therefore, we have a true clone of the sheep class. Thanks again to Brian for the inspiration for this video. Check out his blog at the URL shown here for more articles on design patterns in Java.